Today I want to step through publishing and securing your web application that you've hosted on a virtual machine via Azure Front Door and Azure Private Link. You typically use Azure Front Door service when your application is globally distributed across multiple regions for layer 7 load balancing. But you can also use it if you've just got separate applications in different Azure regions for a way of saving money. Rather than having a web application gateway and firewall in each region, which is a really expensive component, you can use the global Azure Front Door premium SKU, so you can have the web application firewall functionality at that global component and then distribute the traffic to the back end. So you might think, if you've used Front Door before, well, Front Door typically distributes traffic to a public IP or a public endpoint. So we can get around that by using the Private Link service, so we can distribute traffic to a load balancer. And the key here is that the only requirement is that it's a standard load balancer, which means we can use an internal only load balancer and just lock all our traffic down to that private network traffic only. So let's just dive over into the Microsoft documentation briefly and have a look at the Private Link service and how that relates to the Front Door. So I'll provide these documentation links in the show notes, but first of all, the Private Link service, I'll explain it from the right hand side to the left. I think it's the easiest way to understand. So your application will be published on these virtual machines in here on the right, in behind a load balancer, and you'll notice that the network security group on this subnet here is to deny anything. So it's really well secured, and the only traffic coming in is through the load balancer, and that's the key here, is the Private Link service needs a load balancer, a standard load balancer to attach to, and it effectively serves as an alias, or let's say a published service for that load balancer. Now the traffic, or the client that's going to consume the service through the load balancer, comes through a private endpoint, which is just over here. And the thing to notice here is that the two subnets are not connected, so there's no pairing here. And the subnet where the private endpoint lives could potentially be in a totally separate tenant. You'd want to then approve those connections, but it's a really nice solution. Now, how that relates to Azure Front Door, I find this diagram from Microsoft not particularly wonderful, but the incoming requests here are coming through the Azure Front Door Premium and into this private endpoint service, which I should note you won't actually see in your tenant, and then across the Private Link service and into the load balancer. Now, I've drawn this diagram myself in a Visio, so I think it's a little bit easier to understand, so I'm just going to share that with you. This is sort of what the Microsoft drawing is trying to show, that you've got traffic coming into the front door and it's essentially skipping right through to your Private Link service. Now, just to explain what's really happening here, I want to show you what happens in the back end. So what's actually happening is the traffic is coming into a private endpoint, but that VNet and subnet is Microsoft managed. So it's a Microsoft managed private endpoint, and the traffic still comes over to your Private Link service and ultimately then into your application. Okay, so let's dive into the configuration. I'll quickly show you what I've got deployed so far, which is essentially this hub and spoke network topology with only one single spoke. So I've got a firewall so my virtual machine can get outbound to the internet securely. I've got this one single virtual machine here, so I'm going to put IIS onto this machine, and I've actually already set up the IIS. I've got a load balancer with no rules at the moment, and I don't actually currently have the Private Link. So we're going to start from there, I'm just assuming that you're more than comfortable getting a virtual machine set up. We're going to start from setting up the load balancing, the Private Link, and the Front Door. Let's dive over to the Azure portal and get into it. Cool. Okay, so here we are. I'm just going to quickly go to the virtual machine and validate that we've got the appropriate rules set up, and then we'll go from right to left, as it were. So we'll go from the load balancer across. So here's my IIS virtual machine. Just quickly check the network settings. So I've got denial, got it locked down. I'm allowing traffic on ADM 443 from my load balancer subnet, and that's really it. So I'm also allowing traffic from the local network on ICMP-M4 and Azure Bastion, so I can actually remote onto the machine itself. Cool, that all looks good. Now I jump across to the load balancing, and there is no load balancing, so let's add some load balancing for this. So we'll go add existing. So I've got the load balancer already deployed. I'm going to create a new backend pool. I'm just going to say this backend pool is backend Chris Coffee Demo. That's the website that we're going to set up. It's going to be about Chris's coffee. Okay, so that's saved. Let's jump into the load balancer and see what configuration we've got. So we've got a private IP for our front-end IP address, so that validates that the load balancer that I've deployed is a private connection. The backend pool that we just created has been created for that one virtual machine. And let's have a look at the load balancing rules. So there's no load balancing rules. Let's quickly create some. So we'll just go load balance for Chris Coffee demo. The front end IP is our only one that we have on this load balancer. We've got the back end pool that we just created. Let's have TCP port 80. So I might call that, let's just say that's 80. Back end port is 80. And sessions, all the rest looks fine. And I'm just going to set up the equivalent here for port 443. I do want to show you the end-to-end TLS. Hopefully we've got time for it. And it wants a health probe as well. So let's just call it health probe. Yeah. Health probe, and we'll have health probe on port 80. Cool. So that's our HTTP port. Let's have the same rule for port 443 so that we can set up our end-to-end TLS. Use our existing health probe, and that should be good. Cool. Okay, so that should be our load balancing for our virtual machine. Let's jump across to the next component, which is our private link service. So we've got no current private link services. Let's go ahead and deploy one. For our purposes, I'm going to put this private link service in the resource group with my spoke network. So that is this one. Private link service on this subnet hib load balancer demo. That looks good to me. Connect the private link service to the load balancer. The front end IP address for the service is going to be the IP address of the load balancer, of which there's only one. The source NAT subnet is going to be the subnet that we're publishing this to, so I'm going to put that also in the load balancing subnet. And we'll just allow a dynamic IP address allocation. And we'll choose the defaults here and complete that. Cool. While that's cooking, I'm just going to jump over onto the virtual machine itself. I just want to quickly show you that I've got IIS already installed, and I've actually had ChatGPT whip me up a quick bit of static HTML code so that I can have an actual website to display. Otherwise it would have just been the IIS welcome screen. So just quickly jump onto there and make sure we've got everything running. Okay, so the IIS page is working, and I just have to remember which binding I actually set the page up on, so I'll quickly check that. Okay, so I've got this on 8080. So if I quickly go to 8080 on that. Okay, so the page is loaded. Let's change that over so that our main pages, in fact, we'll make port 443 for this one, so not 8080. So let's leave that as is for now, and we'll come back to it and dive back in and see if our private link service is deployed, which it is. Fantastic. Okay, so the next thing we need to do is go and deploy Azure Front Door. So bear with me, this is the big part of the process. So go to Azure Front Door, and what I'm essentially doing is just really deploying a profile. So instead of quick create, I'm going to choose custom create. And I'm just going to put this in the resource group with my hub networking. And we're going to have to go with the premium tier, otherwise I don't think we can do private link. And let's give this a name of, say, front door dot dash AUE dash hib dash demo. Cool, we've got no secrets, but we do have to fill all this stuff in. So let's add an endpoint. So the endpoint here, let's just say is going to be Chris Coffee. Oh, spelled coffee wrong. Cool, and it's generated this FQDN for us here. So Chris Coffee, a random string, AO2 azurefd.net for the Azure Front Door. Now the endpoint needs a route or route, depending on where in the world you're from. So let's create a route. And this is going to be what actually goes to my website. So let's just prefix this with the term route. And I think I've landed on Chris Coffee. So it's going to be Chris Coffee, and let's just call that com. Okay. I'm going to add my domain in here. So this is basically my custom domain. So it's a non-Azure validated domain. It's new, and it's not using Azure DNS, using another DNS service. So the domain that I'm going to use is going to be coffee.christurk.com, and the rest is fine with me. Cool. The patterns to match, there's no special path redirections or anything like that going on here. I'm going to accept HTTP and HTTPS traffic, but any connection that comes in on HTTP will redirect to HTTPS, so the defaults are fine. I like that. The origin group, we don't have one, so the origin group in Azure Front Door terms I think is a bit confusing, but generally this would be what you call a backend pool or a target. So let's create a new origin group. So go OG for origin group, and this origin group is going to be all the servers within the Chris Coffee site, and then need to add the origins. And this is really the interesting piece. So for the origin group, the rest of this is fine. The health probe on HTTP is fine. That's all good. Now the origins themselves are the servers. So if you've got multiple servers, you'd add them all in here. But what we want to do basically is let's have so I'll just call this origin. This origin in Australia East for Chris Coffee. Now the origin type for the private link service is going to be custom, and the host header is going to be coffee.christurk.com, and the HTTP port's 80, that's fine. HTTPS is 443, that's fine. And we're going to enable this private link service. Now what we need here is either the resource ID if you're accessing it in a different tenant, but in our case it's the same tenant, so we should be able to find it. If someone else is providing you the service, then they'll need to give you the resource ID to paste in there. So let's just choose that. Cool, and then this request message is really just for approvals, and you'll see that at the next stage. So let's have AFD private link for Chris Coffee. Keep misspelling coffee. Add that in, add that in. Cool, so I think that's all good. Add that in. And that's really it for the front door, except for validating our DNS records. So click through that. Cool, that looks happy. Let's deploy that. Okay, and we're just going to let that cook for a few minutes. Cool, okay, so that took a little while, but it's done. Now the next thing you need to do, and you must do this, is jump over to the private link service. What happens here is the private link service doesn't get approved automatically, so you need to come over here and approve it. And if I jump into one of these, well, it's actually two here, so let's go ahead and approve them both. Okay, and one of them has actually failed. I'm just going to press on with the demo here because usually I was surprised that there was two there. We only created one link, so perhaps something went on in the back end and it duplicated it, and the one that we've approved worked. So anyway, we have one that's approved. Cool, okay, and let's jump over back to Azure Front Door and get the domain configured. So let's refresh this. Cool, so you can see we've got a domain here, needs verification. So if I jump over to the right and go to domain validation needed, it should give me the text record that I want. Cool, back over in Front Door, you can see that we've got our endpoint and our route set up, but what we've got is a domain here that's not validated. So let's just jump over into the domains. You'll see that we've got this coffee.christurk.com, validation state pending, so crack that open, and we've got a DNS record to go and validate that we own the domain. So most people have done this a million times before. I'm just going to go and create these records over in my DNS registrar and get that registered, and then I'll be back. Okay, so the DNS propagated and the domain's validated. So I just wanted to quickly show you that now that that's validated, what's happening is I've got a valid certificate state, and Microsoft very handily provide you with what is essentially like a Let's Encrypt certificate. It's going to automatically renew. There's nothing for you to do there. So awesome. I also did have, I wanted to sort of call this out, that I did have a DNS state issue, and of course that's because I needed to also create a CNAME record. So what you need to do is create should go just back to the domains actually. So you need to create a CNAME record that points, in my case, coffee.christurk.com to this FQDN. So create that, and at the moment I'm just waiting for the CNAME record to populate so I can configure the last piece of the Azure Front Door. At the moment I can't go to the website, but what is really cool is I can take the FQDN of where the CNAME is pointing to and just go to that, and you can see that my coffee website's now loading. So awesome. So I'm just going to wait for the CNAME to populate. The final piece I want to show you is the end-to-end TLS encryption, so that we can limit the traffic forwarding at the back end to HTTPS only using Let's Encrypt. I'll catch you in a minute. Okay, so my CNAME is propagated and I can access the website, well, sort of. So I want to admit that I've ran into I think I've ran into a problem here. So after the DNS propagated, the website wouldn't load. So what I've done to get it to work is go to the route, and I've just forced the forwarding on the back end here to HTTP only. So that's not ideal, but it is working. So I'll quickly show you. So if I go to coffee.christurk.com, of course it redirects me on the front end to the, if I show you the policy here, all traffic gets redirected to HTTPS. So it is still secure, but we don't have end-to-end TLS. So for an extra bonus, I wanted to quickly explore that end-to-end TLS here with Let's Encrypt. And then we'll change this back to match incoming request, and hopefully all is good. So let's jump over onto the server. So what we'll do is we'll search for, I'm going to use WinAcme. I'm pretty sure there's other Let's Encrypt services, but this is the one that I'm familiar with. So let's download that. Cool. All right, so I'm going to just extract that into C:, let's go Acme. Cool. I'm just going to do this from the PowerShell prompt. Cool, we'll run wax and essentially just follow the wizard. Oh, I've already selected something there and I didn't mean to. Let me quit out of that, run that one more time. There we go. Okay, so I'm gonna go with M here and create it with my own options. I find sometimes it doesn't always work with the default options, so I'm just gonna step through option by option. So I'm gonna read the bindings from my IIS. And I've got that site Chris Coffee, which I've already set up. So I'm going to read from there. Let's select all the bindings from there. And it's detected that the host headers are going to be coffee.christurk.com. So yep, I'm happy with that. Not too bothered about an IIS friendly name. So I'm just going to accept the default, press enter. I'm going to go with the recommended option 4 for single certificate. And the recommendation here is to serve the file from memory, and this is the bit where I find sometimes it doesn't work. So I'm going to try the recommended option number 2 first, and failing that I'll come back and do option 1. So let's go with that, and we'll go with an RSA key and store in the Windows certificate store on the local computer. So all the recommended options more or less. We'll go with option 3 here, and there's no other option, so we should be good to go. I do want it to update the certificate for me on the local server here, so I'll go option 1. Create new bindings on a different site. No, we don't need that. Okay, cool, no additional steps. So it's a lot of things to choose, but most of them are the recommended options. And let's see how we get on. I need to accept the terms of service here, so let's open in the default application. I think that's going to be the browser. Cool, scroll to the bottom, read all that, happy with Let's Encrypt. Yes, I agree. We're going to send typically I'd send my expiry notifications to the support desk, but for the purpose of this demo I don't want to get notified when this expires, so I'm just going to send that to nowhere. And there we go, it's trying to validate my certificate now. This is dependent on the DNS having propagated globally, so if the Let's Encrypt servers aren't aware of the updated CNAME record, it's also not going to work. Looks like everything's succeeded there. So do we want to specify the user the task will run as? So let's just say no. What it's done is it's created a scheduled task for the certificate to renew. So I think we're good. We can quit out of there. And if I go to IIS and go to bindings here, we'll see that the certificate now associated with my site locally is this Let's Encrypt certificate here. They're usually denoted by R11 and issued by. And then if I load my coffee page here, which previously didn't have a valid certificate, if I might just close that browser and reopen Edge. So we can now see that locally on the machine here, I've got a secure connection and it's giving me the Let's Encrypt certificate. So I should be able to jump back here to Firefox, and I'm going to update that route now to match incoming request. The reason why I'm not forcing everything to HTTPS at the back end is the Let's Encrypt certificate does use port 80 and port 443, so I'm going to leave that on match incoming request, which is the setting that I had before, which wasn't loading the website, and I believe the reason is because at the back end my website had an invalid certificate, so the traffic was getting dropped. So I'm just going to speed this along, and once that's saved we'll see if our website still loads. Cool, okay, that setting's changed, and what we should find as expected, so now we've got match. We're basically back to the setting that we had before when it wasn't loading, and I can go and see that the connection's secure. The certificate in this case is provided by DigiCert. That's what I expect, because that is the certificate. I'm hitting the Azure Front Door. The Azure Front Door at the back end will be hitting the Let's Encrypt certificate on the virtual machine itself. Hopefully that helped. When I first set this up, I did find it a bit difficult, especially getting the certificates and the routes to work end to end. So hope that helps someone. Until next time, have a good one.